Hello, this is a quick little video for my Year 9 students who are doing the assignment on waves. So what you need to do is design a poster describing the wave model, and for the extension component you're looking at how the wave model is being used by modern technology. So you might want to do something about microwaves, ovens, or you might do something about your phone and how the waves they interact with waves, and or you might do something on all sorts of modern technology, radio, television, anything you like. But I wanted to show you one little video from a PD that I went to on teaching Einstein's physics. And this gentleman by the name of Professor David Blair, who gave a presentation which I recorded on my phone, and he looks into gravity waves, and that's one of the most recent advances in the use of wave technology, and he's got some really interesting stuff to say about what's happening right now with gravity wave research. Here it is.
The whole story will be for me to go back to the middle of the 19th century, when a guy called James Clerk Maxwell predicted electromagnetic waves. And for a long time, physicists were searching for those. And finally, in 1886, Heinrich Hertz managed to send some electromagnetic waves across a table. And a journalist went to see him and said, "What's the use of these waves?" He said, "No possible use whatsoever. I'm just trying to find out if Maestro Maxwell was correct." Well, it was only about 10 years later that the first radios were made. And now we have mobile phones in our pockets, and and X-rays, and all the ways we use electromagnetic waves. So, so then Einstein came up with this theory about the curved space, but it was actually in 1915 he predicted that had this theory of gravity with the curved space and warp time, and then the next year, 1916, he said, and there will be waves. These waves will travel at the speed of light, but he said, but they're so tiny, they're of academic interest only. No, don't think about even trying to detect them. But then there was a lot of time when people were started to argue whether they existed or not. We're in about the week of the time that a guy called Eddington measured the first deflection over the Centenary of Eddington measuring the first deflection of light past the sun, which proved that space was curved. 100 years ago, roughly today, I can't remember the exact date, I don't know if anyone knows it, but I've actually got about 1 million emails in my inbox. Centenary of Eddington's Eclipse, and there are people on the island where they did it now for some special conference to celebrate that. So that was 100 years ago. We knew that space was bent, and we had this prediction. But then this same guy, Eddington, said, "This is gravity waves. They don't exist." And he said, "Gravity waves travel at the speed of thought." In other words, they're just a make-up thing. And there was a huge argument for about 50 years before people worked out that gravity waves actually did exist and were worth trying to detect. And so then, 50 years later, we eventually, after 50 years of struggle, we built detectors able to detect gravitational waves. And that was in 2015. So we all remember this date, September the 9th. Is that right? 14th. Who said it? 14th. Oh, well done. Yeah,
same day that Malcolm Turnbull threw Tony Evans.
Yeah. So. There's a context. And so what we discovered were pairs of black holes coalescing like this, but then, and we hadn't expected those, and they were huge black holes, and we discovered, and now we know that these black holes like this are colliding in the universe about once every 5 minutes. Each one makes a sound that to us would sound like whoop, and these whoops of gravitational waves are going off every 5 minutes in the universe. and it won't be long before we'll be detecting them that often. But and that poster, which you'll have to look at on the way out, it doesn't show up very well in the not very bright light just there. It's showing all these black holes that we discovered. But then, on the 17th of August 2017, we discovered something else. And that was pairs of neutron stars going around each other. A neutron star is a star that's heavier than the sun, but about the size of Rottnest Island. And two of these neutron stars spiral together and collapse, and they make a whoop sound too, but it's a much longer whoop. It's so long that I can't really do it. You have to start really low and go up, but it takes a minute until the point when it suddenly goes whoop and it's finished. But with that, 1.7 seconds later, came a burst of gamma rays, and it had been predicted that when neutron stars crash together, they would make bursts of gamma rays. But another prediction had been made too, and that's that there was a big mystery in astronomy that astronomers had kept really secret about, or at least they didn't talk about it publicly. But astronomers, used to sort of say they knew where all the elements came from, oxygen and nitrogen, things made in the sun. But they didn't really tell anybody that they hadn't a clue where gold and platinum and uranium and plutonium and things like that are made in the universe. There had been ideas, and they'd all been proved wrong. But somebody had made a prediction in about 1980 or so, that 1990, that neutron stars would make gold. And if that did happen, there would be a special light that would be visible, and a special colour of the light, the spectrum, and that was also observed for this neutron star event. So, and now we know now we've found a second one, and we think we've found a neutron star crashing into a black hole as well. Now we know that each one of those makes huge amounts of gold, and it's just enough to make all the gold that's on Earth and on all the other planets and distributed around the universe. So now we know where gold's made. So it's been incredibly exciting to be uncovering this, but now around the world there's lots of gravity wave detectors, new ones being built and planned, and more sensitive ones, and also detectors out there in space. There's one called LISA, and there are two being proposed in China. There's one being proposed in Japan. And so we're going to see lots and lots of different gravity wave detectors finding more and more stuff. So we're just at the beginning, but behind it all is the fact that these detectors use laser interferometers, like this toy one here, like the one that's in the other room, that's not working because the laser died.
It's working now.
Is it working? So in the afternoon tea time, go and have a look and see this model interferometer that looks like this one, but that one's 4 kilometres long, and the one in there's half a metre long.
It's like a planetary orbit. In this case, it's making elliptical shape. I have a software here in my mobile. It's called motion sensor. Right? So what you do, if you just record the video, and using that software, it traces the path of the marbles. Then you can actually see the spiral or the trajectory. So in this way, students can use their mobile phones to record and make. So the comet 2-Meter-Levy, it somehow entered Jupiter's gravity, and while it was traveling, orbiting, it entered Jupiter's gravity, and then it split apart into probably 25 different pieces, and then fall into Jupiter after 2 years. So we can do that here. If this is a comet 2-Meter-Levy, so try to observe this lump. They're all together. We have two, okay. And when it comes closer, they just spiral, break into different pieces. Let's do it again. Yeah, this is. So you can demonstrate all sorts of different.
The physics is really interesting.
Yeah. So let's do the same thing and see if we know that everything travels through space, and we send 2 light beams again. 1, 2, 3, so.